Hello dear students, myself Kiran Rodge, Assistant Professor, Shivlingeshwar College of Pharmacy, Almala. So in this lecture we will discuss the different methods for determination order of reaction. Before we start our video, please subscribe our YouTube channel SOP Academics and turn on the notification for latest updates. So in last two videos we discuss what is mean by chemical kinetics, what are the applications of chemical kinetics, what is mean by molecularity of reaction, which are the different types of molecular reaction with their specified examples, then order of reaction, what is mean by order of reaction, definition of order of reaction, what are the common order of reaction in pharmacy. Then we will in last lecture we will discuss zero order reaction, half-life and shelf life of zero order reaction, first order reaction, then integral equation of first order reaction, half-life of first order reaction, shelf life of first order reaction, what is mean by second order reaction, integral equation of second order reaction, and half-life of second order reaction, and last one, that is pseudo first order reaction. So in this lecture we will discuss the different methods for the determination of order of reaction. There are three methods. First, graphic methods, second, substitution method, and third, half-life method. Graphic method, substitution method, and half-life method. So there is no straightforward methods to theoretically know the order of reaction. Molecularity provides a rough estimate of a number of molecules participating in the reaction. So the order will be either equal to or less than this number, that is the molecularity. The exact order can be determined experimentally. So we can find out the order of reaction by graphic, by substitution, or half-life method. First, graphic method. So this is a pictorial method, may be more reliable because deviations from the best fit line can be easily observed. Conduct the kinetic experiment and collect the data on the time course of changes in concentration of the reactants. Plot the data on a graph paper as per the general principles of each order. We will get these three graphs: zero order graph, first order graph, and second order graph. Decide which graph gives a better fit for its straight line. The reaction is considered to be that order. That is a simple graphic method. Second, substitution method. Conduct a kinetic experiment and collect the data on the time course of changes in concentration of reactant. Substitute the data in the integral equation of zero order, first order, second order reaction to get the K values. For zero order, K0 is equal to A0 minus AT divided by T. For first order, K1 is equal to 2.303 divided by T into log of C0 by Ct, and second order, K2 is equal to 1 by AT into X divided by 1 minus X. These are the integral equation. Select the order in which K values at different time period remain constant within the experimental errors. The reaction is considered to be that of order. This is simple another method, that is a substitution method. And last method, that is half-life method. Calculate the average K value using the data for 0, first and second order as given in substitution method or graphic method, then estimate T-half value for each time period in the kinetic study. Equations are as follows. Zero order, T-half is equal to A by 2K0. For first order, T-half is equal to 0.693 divided by K1, and T-half for second order reaction, that is 1 by AK2, where K0, K1 and K2 are the rate constant. From the above equation, we can say that zero order, in zero order, half-life is proportional to the initial concentration of the reactant. In first order, half-life is independent of initial concentration of the reactant. And second order, half-life is inversely proportional to initial concentration of the reactant, where A is equal to B. In general, the relationship between the half-life and initial concentration is as follows, that is T half is directly proportional to 1 by A raised to n minus 1. Alternatively, conduct the kinetic experiment at two different initial concentration levels, that is A1 and A2, under the identical condition. Then the half-life T half first and T half second are related as follows: n is equal to log of T half of first divided by T half of second divided by log of A2 by A1 plus 1, where n is called as order of reaction. Now n can be derived by plot a graph A versus time for the two different initial concentration, then calculate half-life value directly from the graph by reading the time required for half of A1 and half of A2. Substitute the values of A1 and A2 and corresponding half-life in equation and calculate n, that is order of reaction. So these are the three basic methods for determination of chemical kinetics or order of reaction. First, graphic method, where experiment is done and the graph is plotted, and just compare the graph of experiment and these official graphs. Whichever the graph fit or whichever graph look like a same, that's supposed to be a order of reaction. In substitute method, all the three integral equation of zero order, first order and second order experiment is conducted, and at different time interval, and select the order in which k value at different time period remain constant within the experiment. And third one, half-life method, in which the average k values using integral equation of order from the substitution method, then estimate t half values by using these three equations, that is for zero orders, for first order and second order. Then a general relationship, that is the t half is equal to is directly proportional to 1 by A raised to n minus 1. Then one equation we can get, or before that, conduct the experiment of two different initial concentration called A1 and A2, and this half-life of determined, that is T half of first and T half of second, and we get an equation, that is n is equal to log of T half of first divided by T half of second divided by log of A2 minus A2 by A1 plus 1. Solve that equation and we get n, that is the order of reaction. So these are the three simple methods for order of reaction. Thank you.